Now let us talk about another very important concept in statistics, which is outliers. Outliers are those unusual data points that stand out from the rest. An outlier is a value that is significantly different from others in a dataset. It might be an extremely high or low value compared to the typical range. For example, if most students in a class are between 150 and 170 centimeter tall, someone who is 210 centimeter tall would be considered an outlier. Similarly, an income of 1 lakh in a dataset where most people earn between 5 and 10,000 rupees is another clear outlier. Outliers can arise sometimes they are the result of data entry errors. For example, an extra zero can be accidentally added while entering data. At other times, they reflect genuine extreme values, such as a millionaire in a national income survey. Sampling variations can also produce outliers, especially in small datasets. We will give more examples of this as we move along in this video series. Why do outliers matter? Because they can distort your analysis. The mean of a dataset is especially sensitive to outliers because just one extreme value can pull all the averages up or down in a significant manner. Outliers also affect regression models, correlations, and standard deviations. That is why identifying and handling outliers is a key part of data cleaning. We will explore techniques like box plots, z-scores, and interquartile methods to detect outliers in a dataset. And we will also discuss when to exclude outliers or to transform them and keep them based on the context of the data. Now that we understand what outliers are, let us look at how to detect them using simple practical methods. There are three main approaches to detection of outliers: visual tools, the z-score method, and the interquartile range or IQR method. We will discuss these methods in much greater detail in later videos, but for now let us just look at how they can be used to detect outliers. First, visual tools like box plots and scatter plots are intuitive and quick. A box plot, as you can see, shows the spread of data and highlights values that fall far outside the typical range. Scatter plots are especially useful when analyzing relationships between two variables. In these plots, outliers often appear as distant points that do not follow the general pattern. Next, the z-score method is often used as a statistical tool. The z-score of a data point tells us how many standard deviations it is from the mean. The formula of a z-score is z is equal to x minus mean divided by standard deviation, where x is the data point. If the absolute value of z is greater than 3, then it is usually considered as an outlier. Next is the interquartile range or IQR method. You can see the formula of IQR on the screen. It is Q1 or first quartile minus 1.5 times IQR and Q3 or third quartile plus 1.5 into IQR. We will discuss these methods in more detail in the next videos. The IQR method is often considered to be robust because it does not assume a normal distribution, which the z-score method does. So, each method has its strength or weakness depending on the data type and the context in which we are doing the analysis. We will discuss more examples and how to apply these methods to clean our dataset in our later videos. Now let us discuss why data cleaning is so important, especially in the context of data analytics, big data, and machine intelligence. Raw data, as collected from surveys, sensors, databases, or from other methods, is rarely perfect. It can be incomplete, inconsistent, it can be duplicated, or it can be riddled with errors and irrelevant information. If we skip cleaning, then we risk basing our analysis on flawed inputs, which might lead to misleading insights and poor decisions. In data analytics, clean data is the foundation for accurate models and meaningful visualizations. Whether you are calculating the averages or building predictive algorithms, the quality of your input directly affects the reliability of your output. As you know, the famous phrase garbage in, garbage out. So, we have the converse also, good things in, good things out. This becomes even more critical in big data environments where millions of records are processed continuously. In these types of systems, even small errors can scale into massive distortions, as perhaps you have heard about the butterfly effect. Machine intelligence systems are also very sensitive to data quality. These systems learn their patterns from data. So, if the data is noisy or biased, the model itself will also reflect that bias. Cleaning ensures that the data fed into these systems is consistent, relevant, and trustworthy. So, we can say that data cleaning improves accuracy, efficiency, and interpretability. It is not just a technical step, it's a strategic one actually. Clean data empowers better decisions, stronger models, and gives us more credible results. Let us walk through the 4 essential steps of data cleaning. These steps form the backbone of any reliable data analytics or machine intelligence workflow. Skipping them can lead to flawed models and misleading insights. Step 1 is removing duplicates. Duplicate entries inflate counts and distort summary statistics. For example, if a customer appears twice in a sales dataset, it could falsely suggest higher revenue or engagement. Step 2 is handling missing values. Missing data is common as we discussed earlier. It can occur due to skipped survey questions or system errors. We can remove these rows containing missing data, replace missing values with a default or average, or use imputation techniques to estimate them based on other variables. The choice depends on context and the importance of the missing fields. Step 3 is fixing formatting issues. These include standardizing date formats, correcting inconsistent capitalization, and aligning categorical labels. For example, male with a capital M, male with a small m, and male written in all caps should be treated as the same category. Clean formatting ensures smooth analysis and prevents errors during coding or visualization of the data. And step 4 is detecting and handling outliers. We have already discussed methods like Z-score and IQR. Once identified, we can drop or investigate outliers depending on whether they are errors or actually meaningful extremes. Together, these steps ensure your data is clean, consistent, and ready for further analysis or modeling. Now, let us look at a practical example of data cleaning using a student dataset, which you can see on the screen now. As you can see, this dataset includes names, grades, and attendance records. But like most real-world data, this set is quite messy. First, we can notice inconsistent entries for absent. You will see that one student is marked as APSNT and another student is marked as absent in all caps, except for the letter B. These variations should be standardized to a single format. This is a classic formatting issue that can disrupt the analysis, especially when filtering or counting categories. Second, you can see that some students are missing grades. This is a case of missing values. Depending on the context of the analysis, we might remove these records altogether. That means we might delete those rows, or we may fill in the missing grades with an average, or use imputation based on attendance or past performance. The choice of what we do with these missing values depends on how critical the missing data is and what assumptions we are willing to make. Third, you can also spot an outlier. One student has a 200% attendance. This is clearly unrealistic. So it can be a data entry error. Perhaps someone added an extra zero or misread the fields. We would flag this as an outlier and decide whether to correct or remove it. So this walkthrough shows how cleaning data is not just a technical issue, it is also an interpretive issue. You need to understand the context, question the anomalies, and make informed decisions. Clean data leads to trustworthy insights, especially in education analytics or predictive modeling. Let us wrap up these two videos with a quick recap and a preview of what is next. We covered the foundational elements of descriptive statistics, including starting with types of data, then moving through levels of measurement, identifying outliers, and finally, the importance of data cleaning. We began by distinguishing between qualitative and quantitative data, and then broke down quantitative data into discrete and continuous types. From there, we explored the four scales of measurement: nominal, ordinal, interval, and ratio. And we discussed how each scale determines which statistical tools are appropriate. For example, calculating a mean for nominal data makes no sense, but it is perfectly valid for ratio data. Then we looked at outliers, what they are, how they arise, and how they can skew results. We explored detection methods like Boxplots, Z-scores, and the interquartile range rule. Finally, we worked through the data cleaning process, emphasizing its importance in analytics, big data, and machine intelligence. Clean data leads to accurate models and better decisions. In the next videos, we will dive into descriptive graphs, and measures of central tendency, which are tools that help us summarize and visualize data effectively. These tools include histograms, bar charts, and key statistics like the mean, median, and mode.